4, and 5. All right. What happened to all of my stuff? There it is. 13/2. Gosh, I'm looking for my controls. They just kind of, like, they're on the page somewhere. But where? That's my calendar. That's not going to be very helpful. Maybe if I just click on this. There they are. Okay. Sorry about that, guys. All right. So we had C4H10 plus O2 makes CO2. No, we had H2O first. H2, well, H2O plus CO2. Okay, and then we had 13/2 right here. What number did we have in front of water? Does anybody remember? We had a 5.
I think it was 5.
Okay. Yeah, and we had a 4 right here. Okay, so we were talking about getting rid of our fraction there. So we're going to multiply. That looks like a B, but it's meant to be a 13. Just so you know. Maybe I'll just rewrite that 13. Just make the 1 a little further away. Okay, that's a little better. Okay, so we're trying to get rid of the fraction. In order to get rid of the fraction, we have to multiply all of the coefficients by 2. So I'm just going to point at all the coefficients. Okay. So the coefficients that I have then are 1, 13/2, 5, and 4. So for C4H10, it's going to be 2 times 1. It's going to be 2. And then for O2, it's going to be 13/2 times 2. So that'll be 13. And then on the other side, we've got the 5 we're going to multiply by 2 and the 4 we're going to multiply by 2. So that's going to give us 10 H2O and 8 CO2. And I know that that is reasonable because when I'm looking at my coefficients now, I'm looking at the 8, the 10, the 13, and the 2. And what I'm looking for here is to make sure that none of those are fractions, and they're not, and to make sure that they can't be divided by the same number evenly. For example, I can't, like, hang on, let me move this out of the way. Okay. I can't divide them all by 2. I could divide the 2 by 2 and the 10 and the 8, but I can't divide the 13 evenly by 2 because I would get 6.5, and that's not even. So that's what I'm looking for. I want to make sure that they're not multiples of something, and I want to make sure that they're not fractions. Does that make sense? Yep. It does? Okay. All right. So what else can I help you guys with?
Can we do another problem with the one that has fraction in it?
Yeah, okay. Absolutely. Oh, and Album. I'm making up your name now, Elvin. Elvin has a question about the exam. Has everybody in here's taken the exam, right? Yeah. Okay. So I can answer your question. What question do you have, Elvin, about the exam?
So there was one question about what is the hybridization and the shape of this molecule. I don't remember exactly what it is, but it was T-shaped. I know for sure. Okay, that's the correct one, but it didn't have the correct hybridization number. Like I double checked. I think I even triple checked. Like I made sure, but that T-shaped wasn't an option. But the hybridization for that T-shaped was incorrect. Like it was Sp2, I think, but that was incorrect. It was supposed to be Sp3 and D, right? That's what T-shaped hybridization is, right?
Something like that. I'm trying to remember what it comes from. It must come from octahedral. Is that right?
Yeah. T-shaped. It's triangle bipyramidal.
Yeah, I think you're right there. So there would be one in the middle, one at the top, one at the bottom. That would be octahedral. Yeah. You're right. Trigonal bipyramidal.
Yeah.
So there would be. Okay, so that makes sense. One here, one here, one here, one at the top, and one at the bottom. Okay, now I see where it was. All right, so it's going to have two lone pair.
It's T-shaped, yeah.
Okay. So when you're counting, you'd be like S, P1, P2, P3, D. So the S, P, 3, D. So what you're saying is there wasn't that as an option?
No, T-shape was an option, but that wasn't. So I clicked the one with the T-shape, but I don't know if that's the correct answer. Like, I don't know if you give me credit for that. And there was another question, same thing with the hybridization. It say SP and SP again for, like, there was for two choices that were exactly identical. And yeah, those were the only two questions I have.
All right.
Problem with two of them too.
All right, let me pull up the exam, and you guys can tell me which one to take a look at. All right, and I will share this one instead. Okay. Oh, wait. Okay. All right. So, this is the wrong quiz. I did quiz 3. I meant to do exam 3, not quiz 3. Give me a second so I can go to the right exam. Okay. Exam 3, there we go. Edit. Okay, now we can see the, no we can't, those all say the word random question. Okay, let me just preview it. Preview. Okay. All right. Okay. So I'm going to go down, and you guys let me know when I get to it.
Oh, there was. I think that one was the one. What's the only time it's
Right here?
11.
But no, this is not the one.
No,
This
no,
one doesn't repeat. Okay, there was one that repeated.
All right. This one?
This one, yes, there is. SP2 T-shaped.
All right, let me see if I can draw right on it. I think I can. So we've got chlorine, and it has 7 valence electrons. And we've got fluorine. It also has 7. and there are 3 of them. So in total, we have 28 valence electrons. Fluorine is the most, almost said fluorine is the most stupid one. I meant most electronegative. Where does that word even come from? Gosh. Today has been the worst day for me and speech. Okay, so chlorine goes there. Fluorine. 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 So that's going to be -6, leaving me 22. All right, so I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So let's see, that would be S, P1, P2, P3, P1, P2. Looks like it would be.
Wait, on the chlorine, there's supposed to only be 2 lone pairs, right? I think you forgot 1 lone pair on with fluorine.
Yeah, that's what I was thinking. Okay, so there's 18.
We forgot one low there on.
Yeah.
The right fluorine, the one on the right.
It's right here. Oh my gosh, that's sad. I was like, I've never seen a structure like that before. There isn't one. Okay.
The fluorine.
Yeah, it's like, let me just make something up, right? Watch this. No double bonds. We're just moving those electrons. Okay. Yeah, you're right. That's not got a right answer. It's definitely T-shaped. That's correct, but it should be not SP2. What idiot even put? This is a typical smart work thing, you know? I mean, it's like, do you know chemistry or not? If they are doing the test questions, they shouldn't be thinking that this is trigonal planar, because it's not. So I'll go in and I'll give everybody credit for that one. So, but you're correct. It is SP3D1.
All right. And there's another question that repeats. Yeah, we still haven't found that one yet.
All right.
This is the one. Yep, this is the one.
Yeah, it have SP3 2 times.
Oh gosh.
Yeah, I think the answer is, let's see, maybe SP. I think I put SP, but I'm not too sure. Yes, I think it's SP.
Yeah. Yeah, so that would be SP. Yeah, I wouldn't worry too much about the fact that there are 2 SP3s just because they're both the wrong answer. I don't know why they're both in there like that. But I'm just glad that wasn't the right answer twice. That would be unpleasant for me. Let me delete this stuff. Yes.
Could you go over number 10?
Absolutely. Give me 1 second. Let me, you know what? I think there's a clear button on here. There we go. That's a lot better. I just have to, okay, there we go. Number 10.
Yeah, I think that was, no.
This one here.
Yes.
Okay. Which compounds' electron pair geometry and molecular geometry are the same? So let's see.
Because I felt like there was 2 right answers, but I'm not sure.
There might be. We'll just draw them out. Let's. All right. So the first one, bromine is 7, fluorine is 7. So that's basically 6 times 7. So it's a total of 42 electrons. So that's bromine in the middle. and then fluorine, and fluorine, and fluorine, and fluorine. I just made that bond longer because I was going to run into the words. So there's not a science reason for that. That's just the words are in my way. Okay. So then I've used 10. So that leaves me 32. I'm going to put 6. I'm going to draw a line like this instead of putting 2 dots just to save time. So that would be 6 electrons. Okay, so this one is going to have a lone pair. So its molecular and electron pair geometry are not going to be the same. So definitely not that one. We'll take a look at pH3. Anybody have a periodic table open?
Yes.
Phosphorus is in group 5, right?
You said bromine? No, phosphorus.
Phosphorus, yeah.
Phosphorus in group 5.
Okay, so that's 8 electrons, phosphorus. Yeah, it's not going to be phosphorus either because phosphorus is going to have a lone pair. This should be an H. You know what they call it when you change one element into another one? They call that alchemy. And that doesn't happen. That's kind of funny. Oh, all right. So I guess instead of chemistry, right here, I'll just do an alchemy. Okay, so not that one. So let's look at SiF4. Silicone group 6, maybe? Is that right? This one? Anybody know what group that's in?
It's 4.
4. Okay, that's right. It's under carbon. All right. So we've got 4 from silicone and 28 from fluorine. So that'd be 32. This one I think would be. I think this one's going to be tetrahedral. Well, maybe not. I don't know. Let's see. I'm not going to guess. Today's not a good guessing day for me. I will guess wrong. That noise you hear in the background, that is my cat scratching on the scratcher. Actually, my daughter's cat. But she's scratching on the scratcher. She's quit doing that now. Okay, so we had 32. We've used up 2, 4, 6, 8. So 32 minus 8. 8 times 4 is 32, so it's 24. So we have 2, 4, 6 times 4. Yeah, so this one is one that definitely would have both the same. And this one would be tetrahedral. All right, so let's take a look at PCl5 and ICl3. I'm going to change colors just because I got so much going on the page. Let's go to blue. So P is still 5, and let's see. Okay, so P is 5. Chlorine is 5 times 7, 35. So that's 40. So we're going to do P, 1, 2, 3, 4, 5. That's 40 minus 10. So we've got 30 left to put on them. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. This one also. Yeah, this one.
Wait,
And
Yeah.
this one.
okay, so yeah, I picked D, and so C is also correct. So
I would cut it for C or D.
Okay.
Yep. Either one.
Okay, so you're gonna give us credit for that if we did C or D, or C and D was already credit?
I'm going to give you credit if you did C or if you did D. So
Alright.
one of those is probably labeled as the correct answer, but the other one is also the correct answer. So I'll just go through and look real quick to see if anybody had put the other correct answer and just mark that correct as I go through and grade. Okay, because I got to grade that one that you had to do by hand. That shouldn't take but a minute. So what else?
Can you also do the math question? Because I think when I was reading it, I read too fast and I didn't know it's asked for atoms of the water molecule.
Sure.
6. Oh, no.
Oh yeah, it did say how many atoms. I misread it. Yeah, so I got the wrong answer for that.
All right.
I have a question for the number 6.
Sure.
If I just put like, I think my answer is 1.05, and then
Uh-huh.
I forgot to put like E plus the like 10 go to power of 24 something. I forgot to put the last part. Is that okay or just incorrect?
I'll probably give partial credit for something like that.
Okay.
I'll look to see if it's set up correctly, and if it's just some little something like decimals in the wrong place or something like that, I probably wouldn't take off, but like hardly anything for that.
Yeah. I forgot to put the last part, so yeah.
Yeah. Let's see. Okay.
Can you also do the question number 3?
Yeah. Let me do this one first, and then I'll do number 3. Okay, so we're going to go moles of water to atoms in water to atoms, I guess. Okay, moles to molecules first. That's what we'll do. Okay, so we've got 2.5 moles of water. I am in the wrong place now. I've crossed my little line there. Okay, and then in 1 mole of water, there are 3 atoms. No. Okay, we're going to go moles to molecules, then molecules to atoms. Okay, there are Avogadro's number. 1 mole equals 3. No. All right. Molecules. All right, I need some more line here. More line here. Okay. And go back here. All right, so in 1 molecule of water, we have H2O, so that's 2 hydrogen and 1 oxygen, so that's 3 atoms. And then that's how you would do it. So the moles would cancel, the molecules would cancel, and then that would give you the total amount of atoms in 2.5 moles of water. All right. So, and you wanted me to show you how to do number 3, right?
Yes.
All right. So let me go back. Oops, 1, 2, 3. Okay. Which one's going to have the highest boiling point? Let me draw. How do I? Oh, there's the button. Okay. So all of them have dipole. Not dipole. All of them have London forces. Okay, I'll do those, and I'll do A in blue, and then no, blue. Okay, and then I'll do B in red, I guess. And then, you know what? Would just be.
Wait, are you going like everything in a row? Because for number A, isn't there supposed to be hydrogen bonds?
Hydrogen bonding and dipole. Yeah.
Okay.
Okay. Okay, that's going to be better. That way I don't have to switch colors constantly. Okay. And then this one's London. This one has London. Oops. And this one has London. All right. This one also has a dipole because of the OH. And it has hydrogen bonding. All right. The next one only has London forces. And then the one below that also only has London forces. Stacks well. This one does not stack well. And the reason it doesn't stack well is because of the carbon that's pointing straight up in B. Let me see if I can just kind of point that one out. This one right there. That makes it where it's not going to stack well. All right. And then the next one stacks well, but it's smaller. All right. And then this one right here is small, does not stack well, and it has a dipole. All right. Technically it's dipole, but I'm just being lazy. All right. So we're looking for something that's big and polar. So E is polar, but it's not big. So if we look at the ones that are polar, we've got E and A. And then if we're just looking to see which molecules are biggest, we've got A, B, and C. E is kind of small, so that marks out E. And marks out D because D is small. B would be marked out because it doesn't stack well. And then when you compare A and C, C would be marked out because it only has London forces, and A has London, dipole, and hydrogen bonding forces. Any other questions?
Can you scroll through the list so if there's any question that concerns me, I can ask?
Absolutely. Give me 1 second. Let me clear this.
Okay, can I see that one? The one, yeah.
This one here?
Mm-hmm.
All right. Sure. Let's see. All right. I'm going to just kind of make a line in between them all. Okay. So when water is converted from a liquid to a vapor, the blank are broken. So we've got to look at what is in that. So water is definitely not ionic. So it's not going to be D. It's not going to be intermolecular interactions because those are inside the molecule. And it's not breaking up the hydrogen from the oxygen. Covalent bonds, those are also inside the molecule. All right. Functional group bonds are also inside the molecule. Really? It's put something right in the middle of my page. Give me just a second. Okay. It's telling me again, you have the cheap version. It's like, I know that. Okay. Let's see, functional group bonds. These are inside the molecule. Functional group would be something like OH, but that's like inside the molecule. Okay, and intramolecular interactions are between waters. So it's definitely going to be A.
What? Wait. I'm kind of.
Wait. No. I got that backwards.
I was
Give
gonna.
me a second. Yeah,
She can hear y'all.
I gave you the wrong answer again. Oh my gosh.
She's a psych.
I don't know what's the matter with me today. Okay. Switch A and E. Intra means within, so it's inside the molecule. And then
That scared me.
That's good.
Oh, are we learning stuff wrong?
no.
There's no way I learned everything wrong.
No, if you learned it all wrong, that'd be my fault too. So all on me. So that's not good. Yeah, no, I got them backwards. Why did I do that? You think it was Monday too?
So the answer sheet, he is the correct answer, right?
Intermolecular. Yeah.
Oh, nice. All right. Just.
And let me scroll through these. Let me.
Oh yeah. I didn't know what I knew what interminators were, but I didn't know what the word superimposed means. So I think I got this wrong.
Oh, this one here.
Yeah, like I know what interminators like anywhere where they have the same like molecule, but they're mirrored version, so they're not the same. Yeah, but I didn't know what superimposable meant, so I just guessed.
Oh, okay. Yeah, superimposable means you can set them one on top of the other and they overlap perfectly. So if you take your hands and you face them with the palms facing each other, then they go together really well. That's almost like superimposable, sort of. But if you take them so that the top of your hand or the palm of your hand is going down for both of them, and then you lay one on top of the other so the palm of the hand is on the back of the other, then you can see that the thumbs are on the wrong side. So that means they're non-superimposable. And so that would make them kind of like enantiomers.
Yeah, I got this wrong because I didn't know what that meant. I knew what interminators meant, but I didn't know what superimpossible, so I just guessed on it.
Yeah. Let's see.
Can you do this one?
Oh yeah.
Sure. All right. Both images in the figure represent benzene. That's correct. Which of the two is more stable and why? If you look at them, you should be able to tell that they are, what is that word? They're hybrid. They're resonance. That's it. Resonance structures of each other. So neither one is better than the other one. They should be equal. Let's see. They're stable or equal because every
should be E.
should be E. Yeah.
Okay.
What do you have not only ignore?
And then let's see what else.
Okay, what about number 12?
Number 12. Okay. So for this one, you look at the periodic table to see what the mass of calcium is. What is the mass of calcium?
It's near 40.
Near 40?
I put 42.
42?
I put 40.
Oh,
Yeah.
also it's 40. Okay. It's 40.
Because I did
40.
and then I was close to that.
So is the mass near 40 or near this one? Okay. Yeah, then that would be C. If the mass was like 48, then it would mostly be made up of calcium 48. But since it's actually near 40, then it would have to be mostly calcium 40.
Okay.
Oh, so we don't have to do anything with the 97%?
Nope, nothing at all.
Oh,
I just put in the calculator and then I calculate and then I choose B. So that's
Okay. All right. Let's see what else.
Can you do
what
this?
about 13?
This one here?
Yes.
Yeah. I think I did. I think I did lone pairs. I think it's A.
Yeah, I'm pretty sure it's lone pairs. All of them have the same electron geometry. So that would be tetrahedral electron geometry. CH4 has no lone pairs. NH3 has one lone pair, and H2O has two lone pairs. The more lone pairs you have, the more it forces the the atoms close together. And so it's going to decrease the angle of H2O most because it has more lone pairs. So that would be decreasing in the number of lone pairs from water over to methane, which has none.
Perfect.
All right.
Oh yeah, this one.
For this
Wouldn't
one?
it be for this one? Wouldn't it be B? Because since it has an F, it
Yeah.
can form hydrogen bonds
Yeah.
with.
Yes, that is correct. Yeah. And two, you can look, they're identical except for the except for the last atom. One of them has chlorine, one of them has CH3, but that's not polar at all. So you can mark D out altogether. So you're just comparing Cl, Br, F, and I. Since F is the most electronegative atom, then that's going to be the most polar molecule.
Okay, what about this one?
This one would be electron-electron repulsive forces. This is called valence shell electron.
Pair repulsion.
Yeah, pair repulsion. I was like, electron repulsion pairs. I was like, I got the P and the R backwards. No, backwards in my head today. Gosh. Sad thing is, you're in my class. You're learning from me. Normally, I'm pretty good. Not today. All right.
Go ahead and ask. Yes.
This one here?
Yes.
Yes. Okay. Oh, wait, no, we did this one already.
Oh yeah, never mind.
Yeah. That one I have to probably give everybody credit because the answer wasn't on there.
Hi, Dr. Kelly. It's me, Jeffrey, but I'm with Elvin right now.
Hey.
Watching together. I was gonna ask you after everyone takes the exam, are we gonna have the ability to look over which questions we got wrong?
Absolutely. Yes. Yeah. And then this one was SP.
This
Okay,
one.
what about this
For
one?
this one, wouldn't it be B? Because since it's asking for a formula unit.
Let's see, which of the following compounds contains the most nitrogen atoms per formula unit? So A technically is a formula unit because it's got two polyatomic ions, ammonium and nitrate. That one has two though, and B has three. The next one is not a formula unit. The one after that is a formula unit because it's two polyatomic ions, and it's got two nitrogen though, so B still has more. And then E, also not a formula unit. So formula unit has to be ionic. So you really only have the choices between D, B, and A, and then B is the one with most.
Can you repeat that? Like formula unit, it has to be in the ion.
Yes, formula unit has to be an ionic compound.
Okay, and I have one last question, but it's not about this.
Sure.
For the homework, is the homework open yet? No.
It will be as soon as I get done here. I'm going to go in. I think I forgot to click the button, the publish button, which I forget constantly. So, I've got all the due dates set and everything. I just had to go through and hit the publish button. So it will be